We're going to be talking about dilation properties in this video. We will be performing a dilation of this rectangle right here and then looking at some of the things we end up with and looking at some various properties that all dilations will have. So in order to do that, we need to actually perform the dilation first. We have a center of dilation here at 1, -1, and I have it labeled, and our scale factor is going to be a 2. So we're looking to create an enlargement of this rectangle ABCD so that it is twice as large. And also, as kind of a secondary part of that, each of the points A through D prime are going to be twice as far away from the center of dilation as they are currently in front of us. So let's start going point by point at a time. From center of dilation to point A, we know that's 4 spaces. So we need A prime to be double that amount of spaces away. So if I know this is 4, I can go down 8 spaces from our center of dilation. And that means we have A prime at 1, -9. For point C, the next easiest one, C prime needs to be double a distance away as well. So from -1 down to -8, that's 7 spaces. So we need to go down 14 spaces. So from 1 all the way down to 15. And we can mark that as C prime. B and D are a little bit more complicated, but the easiest way to think about it is in terms of slope. So from our center of dilation to B, we have to go down 4 and over 2. So I have to double that slope, which means I need to go down 8 and over 1, 2, 3, 4 to make B prime. I doubled my slope of -4, +2 to be -8, +4. Let's do the same thing with D prime. So for D prime, that slope is down 1, 2, 3, 4, 5, 6, 7 places and over 2 spaces. So I need to go down 14 and over 4. So down 14 and then over by 4 would put D prime right here. So let's look at using our ruler to draw our rectangle of our image after we've dilated it from our pre-image. And we can see that we have a rectangle made out of A through D prime right there. So the first thing we kind of have to look at is whether the dilation happened or not. We know based on what we just did that all A and A prime, well, A prime is double the distance away from our center of dilation as A was, and then same thing for all the other points. Well, let's look at the sides. If we count how long each side is, well, this A prime, B prime is 4 spaces. This was 2 spaces. A to C is 3 spaces. A prime to C prime is 6 spaces. And then that holds for C prime to D prime and B prime to D prime. Meaning that our rectangle is both twice as far from the center of dilation and also it is twice the size. So that takes care of one part of dilations. The next part would be whether our angles of our shape are preserved or stay the same. Whenever you have similar shapes that are the same shape but different sizes, you want to make sure all of your angles that match each other are the same. Using graph paper, it's easy to tell that our rectangle started out with 4 90-degree angles. And in our image, we also have 4 90-degree angles. So that means that our angle measures have definitely been preserved. Now, if we look at the side lengths and segments a little closer, well, we know that on the line from our center of dilation as we go down, A and A prime are aligned with each other, and C prime are aligned with each other. So the segment AC and A prime, C prime are in perfect line with each other. But the ones that aren't in line with each other have to be parallel after dilations. If you look at AB, segment AB, and segment A prime, B prime, those based on looking at the graph paper, it's easy to tell that those are parallel. And all the other pairs of sides from pre-image to image also appear to be parallel. And using graph paper for this makes this process much easier to establish. Now, the next part that we want to establish here, we want to use array. If you forget the definition of array would be a line segment where one end is an arrow. It's kind of like if you took a line segment and line and put them together, you would have array where you have a point and an arrow on the two ends. So if I grab a different color, I'm going to draw a ray through A and A prime, C and C prime, B and B prime, D and D prime. And you can see, and I'll do these in dotted lines, that A prime and A, C and C prime are certainly on a ray with each other in green right there. And you can see that they've kind of gone through directly. So let's do that with B and B prime to really prove that this property is going to be true. So if I draw a ray connecting B and B prime from our center of dilation, you can tell that those are definitely on that same ray. And finally, through D and D prime, even before we draw, we can see that our ruler will kind of line them up perfectly. And we can prove it to ourselves by drawing in our ray. It's going to go through both pre-image and image, D and D prime. And that covers all of the properties that you will need to know about dilations. To go over them quickly, we need our segments to be either in line with each other or to be parallel to their matching from pre-image to image. We need the length of the image compared to how far away it is. We have to consider the scale factor to be multiplied by that. So what I mean is that from center of dilation to A, we had to multiply that by 2 in order to get from center of dilation to A prime. 4 spaces away versus 8 spaces away. Third, our angle measures were all preserved. We have 90-degree angles in all our matching corners from pre-image and image. We have rays going through corresponding points from pre-image to image for all of our points of our 2 rectangles in front of us. And we have shown all the dilation properties are true here, and we can make a safe assumption that these dilation properties will hold true no matter the shape, no matter the location of our center of dilation, and no matter the scale factor we choose. Thank you for watching this video on the properties of dilations.